I'd like to kick off the lunchtime panel. It's an interesting situation we're in with a government shutdown where we're forbidden from allowing our civil servants to work. And we have some civil servants in the audience today and around this panel that are happy to contribute, but being direct part of the panel makes it a little bit more difficult and a little bit sticky. We had planned to have Karen Nyberg, who is on space station. I flew my first flight with her. She is a fantastic astronaut from a little town of 61 people in Minnesota. Pretty remarkable. And Mike Hopper, his first flight in space, he just launched not long ago, less than a week ago, or right around a week ago. So he's welcoming himself to space. He's got 6 months up there in space station. We were going to try to get those guys all wired in. However, it takes an army of folks, a lot of them civilians, to make all that happen. We were also going to bring Sunny Williams, classmate of mine, over from Moscow. She is now the director of ops in Moscow for NASA, coordinating that large operation. Speaking of classmates, I noticed our commandant, my classmate, Captain Bill Burns, showed up. Rock on, brother. Thanks for being here. And I think you saw Chris Cassidy. I don't know, are you around here right now? He was around here this morning. He'll be hanging around. There he is, up in the corner. Chris, thanks for coming out here today. I know your real objective is the football game on Saturday, but which is still on, thanks to this soup and everyone else. It's good stuff. So, one of the advantages of having a bunch of astronauts around and connections and living in this area is we were able to re-wicker this panel, and who knows, maybe we even ended up better. I'm going to introduce, actually, for all the panel members, I think we're close by. Come on up here on the stage, please. I'm not going to introduce the panel members. I'll leave that privilege to our Forrestal lecturer from last night. And I'm looking around the crowd here. We're probably 50% midshipmen or so. And I can say from the mids I talked to last night after the lecture, pretty much the unified opinion was that was the best Forrestal lecture they've seen. And that is some pretty high praise, sir. Very, very high praise. In the world of spaceflight, we enjoy an interesting connection with the media. The media is the interpreter for what we do in the business and the rest of the world. And in that interesting relationship, over time, you figure out who you can trust and who you can't trust. I can report without a doubt that Miles has been the trusted agent for the space business for a very, very long time. I don't know if that part of that motivation was the fact that you were trying to fly in space too. We'll take that. That's all good. Miles is a producer and director for PBS science documentary called Nova. Correspondent for Frontline, National Science Foundation Nation Series. For 17 of his 30 years in the business of media, he was working for CNN, which is probably where you recognize his name, his face from. He basically covered every rocket launch we did during that time period. That's how most of us got to know him and trust him and become good friends with him. And I remember it was a conversation we had just maybe a month ago about trying to talk you into doing this Forrestal lecture. He didn't really know exactly what a Forrestal lecture was, but after his son, Miles, who is a midshipman here, talked him into it, it turned out to be a resounding success. You're a remarkable man, a great friend, Miles. Panel is yours. Enjoy your time.
All right. Thank you very much, Ken. I do appreciate it. Thank you. The International Space Station, if you think about it, really it goes back to 1984 when President Reagan announced it at that time as Space Station Freedom. And at that time, it was meant to be kind of an exclamation point to the space race Cold War mentality. Just one more thing we could say we could outdo the Russians on. And it evolved over time in very different ways, and astoundingly, really, when you look at it now, became a partnership with the Russians and changed the face of space forever and the nature of the relationship between the two countries. And I think, you know, as if you talk to somebody like General Stafford, for years and years, whenever Russians and Americans would meet at the engineer or astronaut and cosmonaut level, they got along famously because they all spoke the same language. And I think what the International Space Station has learned is that at several layers, you can develop relationships, technical relationships and strategic relationships, which in and of themselves, separate from space, are worthy goals. And by any measure, I think you could say the space station is a success in the geopolitical realm in the sense that two like-minded teams who care about space got together who were once adversaries and now work together in space. It's an extraordinary thing. And then, of course, add in the other 15 or so nations that are a part of it. And it's hard to imagine a peacetime endeavor of this magnitude that has brought nations together like this. I don't think there's anything there's no precedent to it. So taking aside all of the stuff we're going to talk about on exploration here and what the space station might mean for science and where it might take us ultimately in the future, I think you can say it's done a lot of good right here on this planet in bringing nations together. So let's, we'll continue on that conversation with our illustrious panel here. All the way down the end there, we have George Zamka, class of 1998 in the astronaut corps, Penguins. I believe they're called the Penguins because they were worried they wouldn't fly. Is that what it was? Yeah,
That's right.
Birds that can't fly. But he flew twice, STS-120 and STS-130. And I have to, last night during the Forestall, I was talking about Scott Parazynski and the fact that he was on the end of the robot arm and laced together the solar arrays and saved the day. But George said that he really devised all that. So let's give him credit. That was his idea. Round of applause for saving the space station. Thank you. You know how humble those Marines are, right? Next down the line is Ken Reitler, STS-48, STS-60. He's a gaffer. I believe that's the George Abbey Final 15, right? Class of 87. He's now a professor here, worked at Lockheed Martin, and has a lot of experience on the management end of the space station. Excuse me. Next in line, Bill Shepard, a maggot, right? And as a matter of fact, he coined that particular sobriquet for the class of 1984. Why were they called maggots? Something to do with your SEAL past, right?
Actually, I got that from an instructor here at the Naval Academy in about 1968.
All right. Maggots.
Maggots.
Anyway, for Expedition 1, he was there to open up the doors to the manned stage of the International Space Station, which has gone uninterrupted ever since. And next to me here is Mike Griffin. 4 stints at NASA. One of them is Code A, as they call it, the boss, from 2005 to 2009. Stints in the private sector in between, now in academia, University of Alabama at Huntsville, who will live in journalism and space infamy for telling a reporter once, "I can explain it to you, but I can't understand it for you." My favorite soundbite ever. For a reporter who deserved that in every way. It wasn't me. It wasn't me.
Actually, I'm CEO of Schaefer Corporation now. I left the university about a year ago.
Oh, apologies.
No,
All right.
no
Back in the
apologies.
private sector. And you have like, what is it, 7 or 8? It's your degrees are, I have fewer socks.
I'm sure no one. I'm sure no one cares.
Yeah, I just thought, we're not going to go through that. All right, so let's, I want to begin, Shep, with you. I remember being in the basement there, near Mission Control, in the astronaut condo. It was really strange because you would go to Korolev and you turn down this cul-de-sac and it looked like Clear Lake, Houston. You know, there was this little development. In the basement was where Shep and everybody gathered. And at the time it was really, it was dicey, the relationships and figuring out how everybody was going to work in space and whether it was going to work out. Did you ever have any doubt that this, you know, if we were to be talking about this in 1969, you'd say this would never happen, that this improbable partnership was about to occur?
Well, I got involved in the space station. It was probably the last thing I wanted to work on as an astronaut at NASA because everybody either wants to be up front flying the shuttle or the guys in the back all want to get in the spacesuit and go outside for a walk, and I wanted to do that. So I didn't have any time for space station, which was really kind of wallowing from about 1986 to the start of the Clinton administration. And one of the international partners, a Japanese engineer, very senior guy, and he came to one of our management meetings and he said, look, you guys, you've just done the 6th redesign. You're reprogramming everything. You're changing all the contractors, and you're moving the lead center from Reston, Virginia down to Houston. He said, I don't think you guys are going to make it. And that was 1992, and it's been a real uphill battle ever since we finished the construction of the space station about 2 years ago. The bottom line is nothing in space is easy, and I'm sure that my classmate in the front row here, Frank Culbertson, could speak to that, getting the civilian cargo capacity online to go put stuff up on the station. So I guess my simple answer is we do space not because it's easy, but because it's hard.
As a famous president once said. Now, you talk about the culture of space. What do you mean by that, first of all? And how did the cultures of the U.S. and Russian astronauts mesh?
I think you have to talk about culture on a bunch of different levels. Much of NASA grew up in the early day, the heroic period of space flight, Mercury, Gemini, and Apollo. In my time at NASA, there were many people that cherished that and wanted that to be the model for the future. The Russians see themselves as the leaders in space. They put the first satellite in orbit, the first human in space, the first woman, the first orbit of the moon, et cetera, et cetera. And they look at us as upstarts who have really rode their coattails into glory on the risks and the triumphs that they made. And I think that after living in Russia for 5 years, I think that there's some merit to that. But they have the same problem. They're still in 1957 in most instances. I went to a commission, or actually a wake for a very senior Russian scientist who was Tom Stafford's counterpart. I don't know if were listening to Stafford earlier, but the Stafford-Utkan Commission was set up in 1992 to look at how we could synergize Russian and American space efforts, and they were focused mainly on interoperability and safety and things like that. Utkan died in 1997. I went to a service for him in the Kremlin. 300 of his counterparts got up, they're all Russians, all got up and talked about the great accomplishments Utkan had done during his life. And I thought the most significant thing that guy ever did was try and meet the Americans halfway on a space effort. Not one of those Russians talked one word about anything that Utkan had done with the Americans. So I said to myself, this isn't going anywhere till all these 70 and 80-year-old guys are dead. And the problem is that this is culture. And I found figuring out what the space station should look like, how it should fly, what it needs to be built out of, who needs to build it, even how to pay for it. Those were secondary problems to meshing the cultures, and I would say the technical cultures, of how Americans and Russians and Canadians and Norwegians and Japanese and Brazilians, et cetera, how they do things. I still think that's one of the biggest challenges that we face as a nation, and not just in space. I mean, this goes across a lot of different domains, but that's one thing that the space station is really leading right now, is how it's a great laboratory as to how to make that work.
All right, more on that a little bit later. Let's go back a little bit. Ken, I want you to talk about STS-60. That was the first mission of the beginnings of the partnership, which ultimately led to the dockings to Mir. You flew with Sergei Krikalev. What was that like at the very beginning? Was there a lot of skepticism that it was going to work then? And what was it like working with Krikalev?
Well, my involvement actually went back a little bit further than that. I had come back from my first flight in September '91. I was working in the Mission Control Center. I was in charge of the part of the astronaut office that supports all the missions, the people at Kennedy Space Center, the people who are the Capcoms working in mission support and other things. And a good lesson for the midshipmen, there's always other duties as assigned. So you have your primary job, but then there are other things that come along. And one day, another astronaut, Dick Covey, and I were pulled into our boss's office and told that we were going to stand up an organization called the Crew Exchange Working Group. And we were told that there was a plan by which we were going to bring a Russian cosmonaut, eventually came to be two, to the United States to train to fly on a shuttle flight, and we were going to send a couple of astronauts to Russia to fly on Mir. The way it was sort of couched was a one-time deal, just pretty much like we do in the military, an exchange program. And so along with two other people from the training department, we set up this group to be able to figure out how to take Russian cosmonauts and get them ready to fly on the shuttle with us. Shortly thereafter, I was then assigned to that crew that was led by Charlie Bolden, and we put together a mission that tried to combine some of the best between the United States and Russia to compare how we did business together, how we did science, how we did operations and things like that. It was a very challenging situation from the beginning because, as Bill and many of the other folks who have spoken today, we were cold warriors. And so we did not look at the Russians or the former Soviets as partners or people that we were comfortable working with. And so we had to overcome some of that culture, some of those preconceived notions. But very quickly, upon getting to know the people, those went away. And we started to realize that from a person-to-person, from an operator perspective, we were a whole lot more alike than we were different, and we had a lot in common, and we also shared a lot of very similar kinds of interests. Obviously, one of the biggest challenges was language. The agreement was that we would speak English on the shuttle and we would speak Russian on the Mir, and so we had to make sure that the crew member we were going to train and fly with us was going to be able to communicate in English. We also recognized that the two people that they had sent over to see us were very experienced, very capable cosmonauts, people that did not require an awful lot of hand-holding, even though initially we thought we were going to have to overcome the culture of operating in the United States, but all that went away pretty quickly. At this point, I was a quote-unquote veteran astronaut after one flight. I had 5 days in space. I was training a cosmonaut who had been in space for 15 months. So I leave it to you to see who learned how much from whom. But it turned out to be, from a personal perspective, from a family perspective, and from a professional perspective, incredibly satisfying to be able to work and train with these two. And then Sergei Krikalev was eventually picked as the prime. And we also established early on a little bit of a different kind of path, because we had flown other people on the shuttle before as payload specialists or as guests with minimal training. And what we intended to do here was not to do that, not to repeat that, but in fact make our Russian cosmonaut crewmate a full crew member. So to have training in all the various aspects of the mission, to be able to perform science, to do work on the robotic arm, everything that a normal crew member would do.
Was the shuttle Mir program kind of the Gemini to, the Gemini to the ISS that Gemini was to Apollo, was shuttle Mir to the ISS? In other words, could it not have happened were it not for that?
Well, what we did not understand at this time in the astronaut office was there were a lot of other things going on, discussions about further missions on Mir, on combining the two International Space Station, or Alpha Space Station, with what was Mir 2 to form truly the International Space Station. All that was going on in the background. And at the time, what we were focused on was how do we execute what we were assigned to do, and that is do this crew exchange.
And from where you sat in 1991, of course, the Cold War just officially over the wall down and all that. Were you optimistic it would succeed?
That this exchange program would
Well, the
succeed?
exchange program, any sort of partnership between the U.S. and Russian space programs.
Well, I think most of us saw there was a window of opportunity that had opened because of the political events that occurred through the late 80s and early 90s. It looked like and those of us that had studied some history and knew that there had been other kinds of activities and initiatives in the past to try to look for opportunities to cooperate, recognized that this was yet one more of those opportunities.
George, I remember being down at the Cape right after John Glenn landed, and Bob Cabana, once I was done with my duties on CNN, took me out to the launch pad and to the operations and checkout facility and showed me some of the pieces that he was going to be flying shortly thereafter on Endeavour to put the station, the first two pieces together. And he was talking about how amazing it was that a piece could be built, machined, designed, whatever, in the U.S., and with whatever the tolerances are, a hair's tolerance, and fly into space and meet up with its Russian counterpart, and it all just kind of goes together. I know you guys don't, but does the general public underestimate the engineering accomplishment of the space station?
Well, I think what happens in our country is that there's so much distraction with other things that they just don't pay attention to how much actually goes into the engineering and how complex the vehicles are. Bob mentioned doing the mission essential element tests down at the Cape to make sure everything did fit, and that was hugely important. And even in addition to that, as a crew office, we would be very disciplined about insisting on fit checks or hardware checks where the astronauts that were going to manipulate that equipment would actually do so with the actual build equipment, which would run counter to some of the design plans. So one good story as a result of getting a fit check was on my second flight, we had some ammonia lines that were being developed, and they were essentially blowing up. They weren't handling the pressure well. So the ones that were going to take in flight were developed late. The space station program went to extraordinary measures to get us a fit check in Huntsville so that the astronauts could actually get their hands in the gloves that they were going to be using and make sure that the ammonia lines would connect at the correct places and after going through the proper run distances. And that went flawlessly in space. On the other side, a small detail that can be missed, and they often are, on every flight there was always some minute thing. We were installing the cupola, and we had to remove a protective cover that it launched with. And as we were throwing we call it the towel bar, but it's essentially an over-center mechanism to now allow us to remove the cover, it got caught on some bolts inside the cupola. And as it turns out, the drawings for the cupola, which is the means by which the engineers approved, said, hey, we're good to go, did not include the thickness of the bolt heads. So little things like that can occur and did occur throughout. So with all the effort of all the engineers and the astronauts contributing where they could, with the insight and the aspect that we would have towards the final end game of getting the assembly together, we bring things together.
The Home Depot's a long way away, so it's kind of hard to get that figured out. So how much, I'm sure you've thought about this, how much easier might it have been to build the station without the overlay of this multinational partnership? Would it have been simpler?
Well, I think that the part that kind of held us up right at the beginning was Shep was very familiar with that, and that was getting the initial FGB and Zarya up on orbit, and those were long poles in the tent. And I think those slowed us. When I was a brand new guy and I wanted to fly, I was painfully aware of that situation. However, on the other side, the contributions that all the nations made enabled us to get us up, and using different barter arrangements and other things with crew time that allowed us to get very expensive hardware up there, contributed by all the partner nations to get the space station going. So was it harder? I'd say yes, but at the same time, that probably was the only way to do it.
Well, but let me ask you, and anybody else can weigh in on this one. In a hypothetical, if you had a blank check and you could build the station as one nation, the U.S., would that have been better? Or was the value of this multinational partnership worth the extra effort, the complexity, the cultural disconnects, all those things?
Well, I guess I would answer that question two ways. One, from a programmatic, from a technical perspective, it probably would have been easier to do it as a single nation. The question was whether you would have the resources to be able to do that.
I just gave you a blank check.
Yeah.
So take that out for a minute.
So
Yeah.
the other part of that is, you can't do that because that's unrealistic. And
You're not going to take my hypothetical.
and the fact is that in many ways, had we not had international agreements to be compliant with and to honor those agreements that we'd made to other countries, our country may have chosen not to pursue that. But it was the fact that we had made commitments to other nations that really kept our nose to the grindstone.
I think that is a key point there. You're less likely to walk away from a space program when you're going to upset a multinational relationship.
Right.
There's maybe a lesson in there for how space should be run in general. I've provoked some questions. We'll go with Bill.
Let Mike talk.
All right, Mike, go you first. You go first, then we go to you, Shep.
Doesn't matter what order. Comment I would make is leave aside the blank check, leave aside the issue of it being more difficult to cancel multinational programs. I would say the current administration hasn't found any difficulty in canceling multinational programs. So the point I would make is that...
Well, no, actually, think about that for a moment. Constellation, which was canceled, was not a multinational
No,
program.
no,
if you
it
could
was.
if you could make an argument that it was the same 16-nation partnership doing Constellation.
It was a multinational effort.
At the level of the space station, though?
It was fully intended to be. Our task was to sign those partners up, and we did that. But leave that aside. My point was stipulate all that. In the larger sense, the fact is that the United States could easily, from a technical and programmatic perspective, build and deploy a space station on its own. My friend and colleague at George Washington University now, Scott Pace, points out that the amount of money voted for the stimulus in 2008 and 2009 in that period was greater in real dollars than the total amount of money spent by NASA in its entire history. An easy calculation to do. So the United States, it's a matter of it's a decision. The United States can do those things by itself if it needs to. I would argue that we should not. I have, on a number of occasions in speeches, pointed out that my belief is that the greatest long-term value of the space station is the multinational partnership that created it. The United States, as one of the world's leading nations, has to do things sometimes that don't encourage friendship with other nations. We find ourselves in difficult positions sometimes. It strongly behooves us, in my opinion, to remember that the 1930s should have demonstrated to everyone that isolation was not an advantage. It strongly behooves us to seek alliances and partnerships and activities where we can do things with other people in non-threatening environments and in non-threatening ways, and things of which everyone approves. Every country in the world wants its people to fly in space. Those are activities that we can undertake, that we can lead, that serve to bind allies and partners to us. And if it were 5 times the price, it would be more than worth the money for that benefit alone.
Shep?
Just to pile on, I think we're really getting into the meat of this, Miles, because I saw a lot of stuff in Russia. Russians don't build hardware the same way that Americans do or most other people do. We criticize them. We look at the crudeness sometimes of what appears to be on the surface something that's fairly agricultural. But I can assure you that their approach to getting things done is very pragmatic. And when you sit on a bunch of Russian hardware that's going to take you into space, you feel pretty good that that thing's been fairly well thrashed out before they use it. And I think that their operational record of what they've been able to do with their hardware supports that. We build critical space hardware in the U.S., and we often simulate the design of the hardware extensively. We do a minimum amount of testing with the real hardware because that's expensive. The Russians, kind of the opposite. They would test an engine, dozens of engines to parade rest, and of course they'll blow up on the test stand, but the Russians put the pieces together and they find out, what valve leaked or what blade broke or what seal failed, and they fix that. And at the end of that process, they end up with very, very robust hardware. We don't do that. I'm sure anybody that's ridden on the shuttle to orbit often wondered what was going to happen when you had an engine failure, which fortunately only happened once that I'm aware of in the shuttle program, and you push the throttles up beyond normal rating, to the firewall, and what's going to happen next? Well, everybody's got their fingers crossed that everything in the back of the bus is going to stay intact. The Russians know exactly what margin they have in their hardware because they've tested it to failure. We don't do that. And this is one of the gems of working with other countries and seeing the other approach to how to do stuff that's of tremendous value. And I've got to say that NASA is leaving these gems, these pearls on the floor. We're not picking this up. This is one of the things that goes back to the culture. It's not invented here. We do stuff better in Canoga Park or whatever. And this is a big mistake that NASA has made in the recent past. One more thing, if I might pile on. I was sitting in the audience here almost over 40 years ago and listening to what it was going to take to put men on the moon. This was early on, and this is 68 or so, and we were listening to a Rocketdyne engineer talking about what it was going to take to build the Saturn rocket. And it was a tremendous accomplishment, but I've got to say that most of the people who knew how to design those engines and braze those bells and figure out how to put those pumps and valves and things together, those guys are all dead. And a lot of that legacy knowledge we have thrown away because we're doing something different now. And this loss of critical intellectual capacity is an emerging and huge problem. And this is another reason why we need to see how other people do stuff and take the best of what 16 nations have to offer. And that's why Space Station, I think, is kind of a hood ornament as to how we ought to do some of this stuff.
Well, let me pick up on that. You make it sound like through this partnership, the U.S. really hasn't learned from the Russians, or doesn't want to learn, or thinks it knows better?
Individuals learn.
Yeah.
Some individuals, I will tell you that I learned something about engineering from working with Russians, and presumably some of them learned something by working with us. Those who want to learn will learn, and I still believe that the partnership contributes strong net value, even if we have not gotten as much value out of it as we might.
You were there.
Yeah, I just don't think you can make it such a square wave that we learn or we don't learn. Individuals do over time, maybe not as much as we could.
So what then is the logical next step in a partnership like this? A trip to Mars?
No, I'm well on record as believing that the logical next goal is a partnership like this to establish a base on the moon. It's a much more natural extension than trying to make a big leap to Mars. You could. I'm not aware of any laws of physics that prevent us from going from Earth orbit to Mars, but I believe a much more logical near-term target is the surface of the moon.
So with that in mind, you've talked a lot about if the focus had not been for so many years on low Earth orbit, and all the resources and the knowledge that came out of, that we had in 1972 when the plug was pulled on Apollo. were focused on continuing outward, we'd certainly be on Mars by now. But do you think that the station and implicit in that, the shuttle, did it ultimately end up being a dead end in space?
Well, no, certainly not. I mean, to characterize the space station as a dead end, I mean, I believe I am the one who first said that it was the greatest engineering project in mankind's history. And if I was not the first, then no matter. The point is that the shuttle and station developments and operations taught us how to live and work in space. We know how to do that now, and we don't know the only ways to do it. As Shep has pointed out several times, the Russians do things differently than we do. Other nations will yet learn other ways.
But if
it is not a dead end to say that you learned how to live and work in Earth orbit.
But if you'd had a choice, and you could have made a choice in time between a space station and a moon base, what would you have chosen?
You didn't have to choose. Why? One of the most frustrating things to me is to be confronted at the policy level for years now with we'll do this or we'll do that. The goal of the United States should be to lead other nations and to be the world's greatest spacefaring nation. To say that we will do a space station or we will go to the moon or we will go to Mars is like saying that we're going to build a Navy, and the Navy will consist only of destroyers. So we're going to not have submarines, we're going to not have aircraft carriers, we're going to not have naval air, we won't have any resupply tankers because they're not destroyers, and on and on and on. Our goal with the Navy, since Mahan's work on sea power, was to create a Navy that was prepossessing in its capabilities in all things maritime. That is what made the United States, in the first half of the 20th century, a world superpower. Space is a new medium. If we say we are going to do, we'll do space as long as it's for intelligence community satellites, or we'll do space as long as it's something that a commercial operator can make a profit at, or we'll do space if we have to do it to beat the Russians, or whatever. We're utterly and completely missing the point. Our goal, if we wish to be a great nation in the future, our goal should be a prepossessing presence in a new medium for humankind with all that implies. Space stations in low Earth orbit, a lunar base or bases, travel to Mars, yes, examining asteroids and learning how to do planetary defense, all of those things. The United States should not be a one-trick pony.
George, help us understand what the space station does to make NASA, excuse me, I got a frog in my throat, to make NASA, to make other nations better equipped to think about exploring beyond, to be going outside of low Earth orbit. What can it do?
Well, I think it does so on a couple fronts. One is just the assembly process itself, the testing that went in on the ground to make sure that the assembly went well. There's the experience we're gaining with hardware in orbit, with rotating equipment like that's on the solar arrays, with the effects on the human body, where we're learning things even now from astronauts spending a long time in space. So all those things combined give us a tremendous benefit, and a lot of them were unforeseen, and that's probably the greatest part of it. Is we always design the specifications, have a vision, and go after that vision, but it's in the things that we learn along the way that were unanticipated that I think we learn the most.
So it's a great platform for understanding what happens to the human body when exposed to long duration, but is there more to it than that?
Well, I think so. I talk about, generally, there's the old term that says we explore in space to learn more about ourselves here on Earth, and I think that's true. So learning about the body figures into that. but also the things that we do in space end up benefiting us down here on planet Earth with discovering mechanical processes, finding out how the humans and machines integrate, how to work together as members of different countries and cultures. So I do think the human is a large part of it, and that's why it's important to send humans up in space.
Shep, go ahead.
Yeah, I just want to pile on with one thing, and I think Ken would agree that Sergei Krikalev and Yuri Gudzenko, the two guys that I flew with, were really exceptional people. One of the things that we were proudest of on our flight was to have, we had 3 relatively minor failures, but they were all with equipment that we really needed. And the ground told us to stand by while they sorted out how to fix the stuff. And they came back a day or 2 later and they said, well, we've got the plan to fix it. And we said, okay, what is it? And they said, well, the spare parts are coming up, but they're going to get there 6 months after you guys leave. And so that was not a very good answer. And we called them back about a day or 2 in all these cases, and we said, you know, that thing that went down last week, well, it's back online. And the ground's going, what? You know, and I said, yeah, we tore into the thing, which the engineers in the factories had specifically designed these boxes so the crews couldn't get into them. And we ripped into those puppies and rewired something or moved something around or replaced something. And we brought them back online and they said, whoa, wait, you know, you guys didn't have any procedure. How did you guys do that? And they said, well, you know, do you want us to go back in there and break it? And they said, no, just keep it running. And this happened several times. And it's very parallel to how the colonies got to be the United States. I think a lot about technology and kind of how we got to where we are. Great Britain did a very good thing before the United States was the United States, and they had export controls and technology transfer laws that precluded having factories set up in the United States. You couldn't roll, or in the colonies, you couldn't roll iron plate in the colonies. You couldn't have furnaces and forges. But that really, this is in the late 1600s and early 1700s, but that really sparked something. And people like Slater came over from England with the plans for a water-powered loom in his head, and that sparked the textile industry in the Northeast, and the cotton gin, and you know, things just started rolling after that. And today, the United States probably invents about 80 or 90% of the intellectual property that gets generated on this planet, and I think that's a big part of it. What I'm getting at is, we're going to do this again. We're going to do this on Mars. We're going to do this in low Earth orbit. We're going to do this on a moon base. This is very much a part of who we are. And that's why doing this in a challenging environment like space, that's why it's so important.
Go ahead, Ken.
So if I could touch on something that Shep said, and also to follow up, Miles, on a question that you asked me that I didn't provide a full answer to, and that was, what was the contribution, or what was the significance of our initial crew exchange to the eventual success of the space station? And I really do believe that had we not taken those early steps and followed them up with other steps, which led really to an International Space Station program that was made up of 4 phases. Phase 0 was the initial crew exchange. Phase 1 was the NASA Mir that Frank Culbertson ran so well, that allowed us to fly 7 crew members on the Mir space station. Phase 2 was when we were assembling it, which was what George and Ken and others had a big part in Shep. And then finally phase 3, where we are today and fully operational. But had we not done that in those steps and learned from those things along the way, I don't think we would have eventually been successful, because we did learn an awful lot about how do you make the transition from short duration space flight, the way we were operating shuttle, to the way we were eventually going to have to operate long duration missions on the ISS. And just like Shep talked about you've got to really kind of shift gears and get in a different paradigm. On our flight, we had a similar failure. We're flying a brand new laboratory that had a air exchange system, kind of a air conditioner recirculation system, and the hose connecting those collapsed, which we reported to mission control. Now on the shuttle, we operated very much in a command and control environment. Everything was Mother May I. Much of that was to make sure everybody was on the same page. It wasn't any big surprise because everybody knew what was going on. Second of all, because on the crew, many times we did not have enough situational awareness or insight into things that were going on. So we dutifully reported the situation. Mission control gave us the standard standby out. And so a couple of hours went by, a day went by, and no word was coming back from mission control. So our commander, Charlie Bolden, said, Sergei, this is a joint U.S.-Russian mission, so we need to operate more like you do. So if we were on Mir and this happened, what would you do? And Sergei said, well, we would wait until we were out of communication with the ground. And we would go fix it. So Charlie said, great idea. So we had a very short communication gap, but we've had our plan together, and as soon as we were out of communication with the ground, we came up with a solution. We installed it, which was just a simple plastic sleeve inside this collapsed rubber hose, and got everything working, and when we came back on communication, we reported to the ground that everything was good, which we got the same reaction that you got. What? But as we explained it, everybody got more comfortable with that. The more you operate in that way, and the more you start thinking about the ways that need to be changed, the more comfortable you become.
You're not suggesting there's tension between engineers on the ground and astronauts in space, are you?
Not at all.
No, that never happens, right?
That's right.
I tell you what, before I forget, we do have, before the unplanned, well, the unnecessary, whatever you want to call it, work stoppage, we did get a little message from Karen Nyberg and Mike Hopkins from the space station. Let's roll that and listen to see what they have to say.
Hello from the International Space Station. I'm NASA astronaut Karen Nyberg, here with my crewmate, NASA astronaut Mike Hopkins. The coolest thing about my stay here for the past 4.5 months has been the wide variety of activities that have been keeping us busy. Everything from working on innovative science, to conducting spacewalks, to the rendezvous and docking of several vehicles. Just a couple days ago, we welcomed the second U.S. commercial cargo vehicle, Cygnus, to ISS. We've been very busy. Looking ahead to the next months on the station, I expect that my crew and those who follow will continue to expand on the neat science we're doing here and sharing the unique experience of living in space with everyone on Earth.
Hello everyone. Well, I've only been on station for about a week now, and the coolest thing that I've done, as you can imagine, is floating in space. It's an incredible, amazing experience. I don't think it will ever get old. It was also very cool watching Luca, Karen, and the whole team capture and dock Cygnus. Now, over the next 5.5 months, my crewmates and I will really continue the work that the previous expeditions have done. A lot of that will be focused as a national lab on science, where we'll be doing over 200 experiments, such as looking for origins of the universe with the alpha magnetic spectrometer, or understanding how viruses in our bodies behave in microgravity. So from all of us from 260 miles above the Earth, enjoy your day exploring the past, present, and future of human spaceflight.
There we go. That is a hairstyle which cannot be repeated on the planet, isn't it? Another advantage to going in space. Picking up on that ideas that you were just talking about there, Ken, the idea that the dynamic has changed, and Shep, if you want to weigh in on this as well. To what extent does learning about long-duration spaceflight, space station, change the way you think about what kind of person you want to have as an astronaut?
I think it changes everything. And in fact, I believe the selection process that has gone on traditionally has changed significantly for long-duration crew members because of that. We learn a little bit more every day about what it takes to be successful in space on long-duration flights. We learned a lot of that from the Russians in terms of what it took in the selection process, both from a mental perspective, psychological perspective, and a physical perspective. So I think we've encountered and incorporated a lot of that into how we select crew members as astronauts and also how we assign them together as a crew.
So, George, who's the ideal person to send to Mars? I mean, you don't really need a test pilot to go to Mars, right? You need somebody who's probably good at breaking down a 67 Chevy or something, right? I mean,
You know,
somebody who's handy in a pinch, right?
let me paint a little picture of the interpersonal situation that's up there so folks can understand. When you're on the space station, you are living day to day with 5 other faces that don't change. Unlike down here on Earth, where if you're having a bad day with someone or it's not working out, you can't go away, you can't hide. Those people are going to be there. So the smallest things can potentially escalate into larger things, and crew members have the potential of isolating themselves because they're not getting along, and it can be very stressful. In addition to that, they have a computer. It's your schedule, your daily schedule, and it lists the things that you have to do. And there's this red line that marches across the screen and tells you where you're supposed to be on the schedule. And you try to stay ahead of that red line, but it doesn't always work out. And if you start falling behind, the temptation's there for the ground to call up and say, hey, how's it going? And that may not be the question you want to answer at that particular time, or other folks can say, hey, look, this task that was organized for an hour and a half is taking me longer, we'll need to reschedule. But the point of that is you're continuously watched, continuously thought about. So the folks that need to do that need to have the interpersonal skills and resilience to thrive in that situation. I think the office has gradually been getting really good at identifying who those kind of folks are.
Boy, chasing the red line every day. So you feel like you're a greyhound after a while or something, I imagine. Go ahead, Shep.
Yeah, I think one of the things that George is spot on, one of the things that implies is think about being in an expeditionary situation on the moon or Mars, and you have real substantial delays between things that you see happening in real time in your world and somebody back in the U.S. or elsewhere who's going to move that red line on you. And we have not thought enough about what's the right model for, who's in charge of what here. And again, we're back with the same culture that got us off the ground in space and to the moon and back safely, but it's not the right culture for what's going to happen in the future. Crews have to be able to have a lot more autonomy, and it's going to be like being on a sailing ship, if you will, in the 1700s out in the middle of the Pacific. I mean, you're going to be left somewhat to your own in contrast to how we operate today. And we haven't done enough thinking about how we're going to bring these changes and what they mean for who ought to fly and what their job should be while we do it.
Well, yeah, I think about that Mars 500 experiment, which you all are familiar with, but just for anybody in the audience, this was putting, was it 6 or 7 people inside a giant gerbil environment in Moscow to live out the length of time that would be equivalent to a Mars mission with a simulated time on the planet and so forth. And they managed to get through it, but there was a previous version that ended very badly with a little too much vodka and somebody feeling that it was a New Year's celebration that did not go well in simulated space, put it that way. So the point is, can we really learn who to put together on a mission by sticking them in, a room for 500 days and seeing if they come out okay? Or is there some other way to figure this out? Does the space station afford an opportunity for that? Or is that apples and oranges because you're still only a radio call away?
I think each one of those has a little different piece to play. You gain a little more knowledge from each one of those kinds of analogs of space flight, whether it be on the ground or whether it be in space. I think we learn more and more as we start to probe a little bit more. I think that I like to use the analogy of the fact that the way we operated shuttle was more like a sprint race as opposed to a marathon. And just as the runners in the audience know, you come at that race from a different mindset, different perspective, different strategy, different way of thinking about it. It's the same way. We learned a lot in our process of why the Russians did what they did. For example, they made a lot of reliance, because of the limitations of technology, on amateur radio to maintain connection with the ground. We now have on the International Space Station a computer-based telephone that allows crew members to call any number on the ground that they want, and they make good use of that to maintain contact with humanity, with their friends, with other parts of civilization. The same sort of thing comes to play in the way we think about how do you keep connected with society. Right? We had a tradition in mission control at NASA that the only person that would talk to the crew member was the Capcom, another astronaut. That one single individual represented the entire ground control team, and that was the only person that made any conversation. We went to Russia and we visited their mission control, and we found out that quite the contrary. Any visiting diplomat or celebrity or entertainer that was in Moscow to give a concert was immediately brought to the Mission Control Center and put on the phone to talk to the cosmonauts, because it gave them entertainment, but more importantly, it maintained that human contact. We've now taken that on as part of our concept as well. So I think we are learning about how to do things differently.
I used to routinely get calls from the station during my last gig at NASA. I guess guys would get so far down the totem pole of interesting people to talk to that eventually
they'd even call you.
They even call me.
Well, what about the space station? You know, it's a good platform for learning how to live in space and work in space and understand the rigors on the human body. But one of the ways it was sold initially to Congress was as a platform for, you know, curing the common cold. Is that overstated?
I'm going to take a whack at that.
Yeah.
It's very difficult to, I think it's unfair to say that the station was sold as a platform for curing the common cold or anything else. Certainly early on, the scientific advantages of a laboratory in space were a primary selling point. I personally believe that can and will come true as long as we maintain a commitment to the station, but we're not going to find what we expected to find. We'll find other things that people had no notion about. I think that's very typical of what happens with scientific and equally engineering investigations and projects. I think you have to drop back and ask yourself basic questions. We know that human cells secrete calcium, bone cells secrete calcium if given the chance in zero G. We know that there are harmful interactions between radiation and cell or immunology that do not occur on the ground, but occur in space. If we pursue, just speaking about life sciences, if we pursue the fundamental reasons why those things take place, how does a bone cell know it's in zero G? Does it have a G meter on it? I mean, how does it know? What causes that bone cell to want to behave that way? When we begin to understand the fundamental mechanisms that go on just in the life sciences, we will answer the direct questions, but our paradigm for how biology works will alter as a result of those understandings, and there may be 1,000 other things that come out of it. It could be like the discovery that matter is made of atoms, and that those atoms break down and produce or absorb energy when that happens. That has profound effects on physics and chemistry. So just within the life sciences, the value of trying to understand what happens to organisms in zero G will confer all sorts of benefits that have nothing to do with spaceflight. And we have a new laboratory in a new place, and if we utilize it, we cannot fail to benefit.
The key being utilization, though.
That's
right
not my,
now it's supposed
that's
to
not
stay
my
up.
fault.
It's supposed to be up there till, what are we saying, 2020 now?
Well, I think the official commitment is 2020, but I mean, I'm going to have to go on record of saying, you know, we spent 25 years, and you know, I was involved in the station redesign in '93, and in all the plans. I was chief engineer in those years of the agency, and was involved in the efforts to build the Russian and American partnership, as were so many others. We spent all this effort, all this political capital, all this fiscal capital to build a space station. Why would you think about anything other than trying to keep it functioning as long as you possibly could? I mean, who builds a laboratory on Earth? Who builds a laboratory on Earth and says, you know, we're going to keep this thing running until January 1st of 2021, and then we're going to blow it up? I don't know of another large capital project on Earth that somebody puts a sunset on like that. A date comes and we're going to destroy it.
Well, you could make an argument that by giving it such a short window of opportunity, we'll never know what the scientific opportunity might be.
Well, certainly, because if I'm, you know, what you would like to attract are, and I'm going to put in a plug for the engineers, being one, you want to attract world-class scientists and engineers with ideas that probably weren't thought of when you built the station. We hope they're not thought of, because we would like people to, I don't want to look back and say the most creative I ever was 15 years ago, right? That's bad. So we'd like to think that people are going to continue to come up with new ideas for new investigations, new engineering ways of doing things, and using the station as a laboratory to learn that. Well, if you're looking to attract the leading lights in any field, that's not going to be somebody who says, well, gee, by the time I get to design, build, and fly one time and get my results back, you know, somebody's going to put it in the Indian Ocean. They will go look to spend their career on something which is going to be there for them. I mean, a multinational partnership just built the world's biggest particle accelerator on the Swiss-French border. How many particle physicists would want to be working on designing experiments for that particle accelerator if they thought the French were going to blow it up in 2020?
I was just told we have 5 minutes. I'm sorry. If there are any questions, please let us know, and we'll try to get to you. Shep, you had something, then go down to Ken. Go ahead, Shep.
Well, I was just going to say that, and George and Ken can back me up. It's a strange thing when you're on the space station or you're in space for any length of time. Remarkable in the sense that you wake up and you're looking out the window and you're seeing Kilimanjaro or the Himalayas or the Amazon or Straits of Magellan, and you've already seen them 4 times that morning in your previous passes over the Earth. And you look over to your buddies and say, hey, we got any more coffee in the galley? and the point being is that the human species is tremendously adaptable, and that was what was very surprising to me, that how normal it seemed to be in this totally unreasonable environment. We've got astronauts and cosmonauts who live in space right now 24/7 today who don't see themselves really as part of Earth anymore. They're certainly going to come back, but for right now, they're living in a different place. And the idea is that if you want to answer the question, what's possible for the human species? You know, where are we destined to live and work and be functional? Is it this one blue orb in the cosmos, or are we going to be going somewhere else? I know for sure that you're not going to get that answer if you don't do things like space station and these other explorations that are planned. So that's, to me, the big picture. That is why this is important and should be sustained.
And to build on that, the aspect of international cooperation is, I think, one of the legacies of the space station and should be. But to do that, it requires relationships. Relationships are take a long time in many places. You just don't walk into many countries and shake hands, sign a contract, and walk away. It takes time, it takes effort, and you have to work at it day by day. And over many years, you develop the relationship to the point where you can have enough trust and confidence to be able to do business. General Stafford this morning, through his work with the Russians on Apollo-Soyuz, really has been instrumental in leveraging that relationship to allow us to do the things that we've done through the International Space Station program. Truly is a remarkable thing. The other point is the video this morning. We talk a lot about how hard this is and how hard we work and how difficult it is to be in space. But for the midshipmen, the video today, to me, really pointed out the fact that when you can have fun and work hard, magical things happen. So don't think about it just from the fact of it's all hard work, but try to have fun while you're doing that hard work.
George, closing thoughts?
Sure. One thing we didn't mention this morning is the inspiration side. I think seeing that video just gave me a tingle, knowing that, hey, I know Mike, I know Karen. Being in the audience and watching the earlier panelists, they inspired us. And so we'd see other space travelers, and it would get our thoughts organized towards goals and things we wanted to do. And astronauts on the space station do that now for others. So that's perhaps the most important thing, I think, is that folks can see that we have humans living in space, can identify with them, and maybe can follow in their footsteps.
All right, I apologize for not leaving more time for questions. We'll get a couple in here. Okay, you, up there, go ahead.
Gordon Reitler, class of 1975. Once we get beyond the fiscal questions about how long can we keep it up, shouldn't we be talking about what can we add to the space station? I mean, we know about the Bigelow agreement with NASA to put an inflatable module on, but I'd like to hear what the panelists have to say about what else we should be doing up there, what we should add to it.
Yeah, one of the aspects of Space Station is that it gives us a platform to be able to do quite a bit of development for some of the systems and the concepts that we're going to need to do exploration. It provides that platform and all the infrastructure necessary to be able to do that. And that's really one of the things which I believe in the next few years, as we're getting more serious about exploration, it will start to be lent to.
Wasn't the centrifuge one of the things that was a big omission?
I was going to say the centrifuge,
yeah,
because
that would probably be high on everybody's list.
Because if you are interested in life and material sciences, the set points of 1G on Earth and 0G in orbit are very useful, but very often what you would like to explore are amounts of gravity in between 0 and 1. The centrifuge would be not ideal for that because it would be limited in scale size, but it would be enormously helpful.
I think we also have an opportunity to do a deep space propulsion testing up on the space station with high ISPs.
Like a plasma kind of thing?
Right.
That would be another thing.
All right.
Yes.
Yeah, go ahead. Excellent, excellent.
I'm sorry my country has such a puny space program. That's because we have a puny government. But it's fine. When we get a sensible government in England, we in the Tory party are working on that. When we get a sensible government in, we'd like to come in with Mars, obviously. We can go to Mars. Would the panel agree that the space station has set the tone for the Mars mission? Because any Mars vehicle has got to be assembled in space. There's no way we'd be that short to try and get a vehicle to go all the way to Mars up through the atmosphere. You want to assemble your Martian vehicle in space. You want to power it with nuclear reactors using the US Navy and the Royal Navy's experience and expertise in nuclear reactors. We've already got the reactors. We take our space to Mars, we fire engines,
Go ahead.
orbiting space food, we have public galleys and canteens and plenty of coffee. Because when they the reactor, one thing we do get is lots of coffee. Is that the way forward? Doesn't the expertise and experience of building the space station is going to stand us in good stead in the future when we start assembling serious spaceships to go and explore the rest of the solar system?
You sound like von Braun. That's big, that's big. It's good.
Von Braun was a German.
Oh, yeah. Sorry about it. Aside from that one part. Philosophically. Anyway, go ahead.
So is King George.
Real quick, because we're running out of time, sir, I think you're spot on. My personal view, going to Mars, it's going to be 3 or 4 pretty key things. It's going to be big vehicles, really big vehicles, probably more than one. Things that are too big to be launched in one shot, but we're going to try and, we don't have the lift capacity now to get stuff up in really large quantities. We're going to build heavy lift vehicles to do that. It's going to be assembled in orbit. It's going to be international in character, lots of different capacities from different nations. It's going to have a crew that's highly self-sufficient, very robust capability, lots of ability to survive failures and damage and whatnot and keep on going. Space station today is all of that. So I think that all those questions really as a program are behind us.
All right, we're going to leave it at that. Gentlemen, thank you very much. I appreciate it. Great conversation.